Okay, this should be a pretty quick one. We're going to solve quadratics by completing the square. And what that means is you turn a polynomial into a trinomial into a perfect square trinomial, which factors to a binomial squared. And then you're going to take the square root of both sides. But in order to do that, there are some rules. The lead coefficient must be 1, and you need to get the first two terms by themselves. Oh, also the first thing you should pay attention to, I already have it highlighted, so I should pay attention to that. The right side must equal 0, at least to begin with. So we're going to add a 2 to both sides and then rewrite it. So x squared minus 3x minus 130 . And actually, I kind of gave you something false. That was kind of silly. On this one, what we actually want is we want the two first terms by itself. So we did not have to start with the subtract 2. What we could have done instead, and should have done, we want only the first two terms. So we're going to add, instead of subtract 132, we're going to add 132 to both sides. And negative 2 plus 132 is positive 130. Okay, now you have it in the mode that you want, and you need to add the c value. But if you add something to one side, you have to add it to the other. Remember the equality properties. And this is how you find the c value. You take half of the b value. So in this case, half of negative 3, and you square it. Well, negative 3 squared is 9, and 2 squared is 4. So we're going to add 9/4 to both sides. Oh, this one's really ugly. All right, so remember what I said. Whatever simplifies on the inside, when you do the perfect square binomial, you could say x subtract 3 halves. The other way to write that would be 2x subtract 3. But that's okay. We'll leave it just like that. Now, with your calculator, you can just do 130 plus 9/4, or multiply 130 by 4, and I believe you're going to get 520. Yeah, 520 plus 9 all over 4. So that is 529 over 4. So I would be doing taking the square root of each to check, because my guess is 529 might be 23 squared. And 4 is 2 squared. So when we take the square root of both sides, so let me grab so square root of 529. Whoops, I have to get the calculator. Yeah, this is going to be positive negative 23 over 2, because the square root of 4 is 2. So now we have, when we take the square root of this side, that cancels, leaving x subtract 3 halves is equal to both positive and negative 23 halves. So now we're just going to add 3 halves to both sides. So 3 subtract 23 is negative 20 over 2, which is negative 10. And 3 plus 23 is 26 over 2, which is 13. So that would be 2 real rational roots. And that graph negative 10, positive 13. That graph is going to be doing something like that. Okay, so now we still want to get the first two values by themselves. So we're going to add 68. So we have 8k squared plus 20k is equal to positive 60. However, in order to complete the square, the lead coefficient has to be 1. So we have to divide each part by 8. So that gives us k squared, 20 over 8, plus, they both have a 4 in common. So that would be 5 halves, k. Now we can put plus blank. 60 over 8, they both have a 4 in common, leaving 15 halves plus blank. So we're going to take half of 5 halves. Well, 1 half times 5 halves is 5/4, and we're going to square it. Well, when you square 5, you get 25. When you square 4, you get 16. So we're going to add 25 over 16 to both sides. But now be careful. Remember, when you put this in the binomial squared, whatever this simplified, the b divided by 2, that's what's going to go right there. So k plus 5/4 is equal to, these need the same denominator, so we're going to have to multiply top and bottom by 8. So 120, is that right? 8 times 15. Yeah, so that's 120/16 plus 25/16. (145) is not a perfect square. So when we take the square root, positive and negative, I should have left room for that. Sorry about that. Positive and negative is very important. So we're going to get k plus 5/4 is equal to positive negative. Well, 4 is in the denominator. I'm going to come over here. Oops. (29) is prime and 5 is prime, so we're just going to leave it as square root of 145/4. So we're going to subtract 5/4. So we have our two k values. K is -5 subtract root 145 all over 4, and -5 plus root 145 all over 4. All right, that's completing the square.